Welcome to EC&M Tech Talks. This is a series of how-to videos where we take a look at everything really from basic theory to the equipment that we install and use out in the field to the various codes and standards that we have in order to install and maintain that equipment, all really based around what? Safety. Today, we're going to be talking about electrical safety. And the reasons that we talk about electrical safety, to make sure that we don't get shocked or that we don't get burned, and protect other people as well. Now, these Tech Talk videos are brought to you by EC&M Magazine, or ecmweb.com, Electrical Construction and Maintenance. And so what you want to do is you want to go to ecmweb.com if you haven't. And in the upper left-hand corner, there's a drop-down menu. Hit that menu button, and the very first thing you're going to find is the members portal. Click on that members portal and go there and sign up. It's free, and you'll have access to tons of information about the work that we do out in the field in the world of electrical construction and maintenance. And I'm Randy Barnett. I'm an NFPA certified electrical safety compliance professional, electrical inspector, journeyman electrician my whole life. And today, our purpose then is to take all of that wealth of information that's in the NFPA 70E standard and kind of condense it down into an understandable format so you, the worker, can go out there in the field and get your work done without being overwhelmed and wondering if you're really following the 70E requirements or not. As I say, it's always just some electrical common sense. If you understand the requirements and the regulations and how you can get hurt with electricity, nobody wants to get hurt. So it's just a matter of applying those rules and regulations to keep yourself safe out in the field then, okay? So the first thing, I'm talking really to three people today, three groups of people, I suppose. One, we certainly have our qualified workers. And if you're out there doing electrical work, then you're probably a qualified person. And so I want to once again break this 70E standard down for you into something practical. If you're trying to learn the trade, if you're beginning into the trade and you're trying to learn this 70E information, hopefully this will give you a good practical overview of what it's all about. And then maybe you're in supervision or management, you're responsible for an electrical safety program. You're responsible for electrical work that's being done out in the field. In that case, then you need to jump into 110.5 in the NFPA 70E standard. Section 110.5 identifies 13 different requirements that you need in your electrical safety program. Now, the first one of those tells you that your electrical safety program has to be written, documented, and then it has to contain all of those other elements. So jump into 110.5, make sure that your electrical safety program encompasses all those different areas. Now let's get down to work. Let's say that our job was to go out and pull the cover off of this panel, make sure that it's all de-energized. Maybe it could be a service panel, but let's say it's a sub panel and it's being fed upstream from a feeder breaker. So we have already locked out and tagged out that feeder breaker, and now we're going to come in and verify that this panel is in fact de-energized, that we got the right breaker upstream, and then we can do the work on the buses as we need to replace breakers or whatever it is we're going to do then. Remember, anytime you have to do energized work, you have to have a electrical safety work permit. So be sure and get into those definitions in Article 100. Some key definitions are working on equipment, barriers, barricades, electrically safe work condition. Get into Article 100 then in the NFPA 70E to make sure that you understand the requirements that are inside the standard then. So the first thing we always have to do, there are 5 items we're going to go over today, 5 major areas, I should say, if we're going to go out and do this job out in the field. The first thing we have to do is we have to identify the hazards. We have to perform a risk assessment. There are 3 reasons that we do the risk assessment then. When it comes to electrical work, we have to do both a shock risk assessment and an arc flash risk assessment, because as I said earlier, that's the 2 ways we can get hurt, shocked or worse yet electrocuted, or we can be burned. That's what we don't want to have happen to us. So the purpose of the shock risk assessment, we identify the hazard. We look at the label on the equipment. If you don't have the label on your equipment, go into Article 130 of NFPA 70E, and you'll find something called the PPE category method. And that will solve the problem for you as to how you can determine what the potential arc flash incident energy might be coming out of a panel like this if you haven't yet done an incident energy analysis. But by all means, get your incident energy analysis done then on all of your equipment. Now, once again, go back to 130, or go back to Article 130 in NFPA 70E and research all that information. So we perform a risk assessment to identify the hazard. Shock risk assessment. Maybe this is a 240 volt panel. It was on our label. So if this is a 240 volt panel, that's our shock risk when the cover is removed, isn't it? Now, if I have something like on a service panel, by the way, 230.62C of the NEC, there's a 2020 requirement now, it's new for the 2020, that requires on service equipment that I have this barrier in place. The purpose of the barrier is to prevent inadvertent contact on my service equipment with the incoming service bus bars or service conductors. So if I'm going to terminate if this were a service panel, and I were going to terminate my service conductors, in this case on either side of the main breaker, I would have to install one of these little plastic caps or barriers, as they call it, over those termination lugs. And you can see down here, there's a little hole that allows you to stick your meter in order to take a reading, see whether it's energized or not. So I'll just put this in place and show you where it goes. Just snaps in place like that then. So that's if it were a service panel. Now, other things you'll obviously see out there in the field is Lexan shields, trade name for a polycarbonate material, a clear plastic shield that we often see. Keep in mind, those only protect you against inadvertently touching something and being shot. Those shields, these barriers do not provide you any arc flash protection then. So anyway, so we do our risk assessment on the shock hazard. We find it's 240 volts. And then we have to think about what is the likelihood if I wear all my PPE, my rubber gloves, follow all the safe work practices, establish my barricade, the equipment's safe to work on and so forth. What is the likelihood that I get hurt? And if I do get injured, what is the severity? So I look at likelihood of injury or damage to health, and I look at severity. If I'm not comfortable that I can do this job safely, I go to the next step, the third step. What can I do in order to reduce the safety inside of this panel so that I feel that there's minimum likelihood, and if something does go wrong, I will not be injured at all? If I cannot feel comfortable, if I do not feel safe, I'm not going inside of that panel. We're done. If there's no way to work safely on this equipment, we don't work on it then until we de-energize upstream or whatever it is we have to do, obviously. Okay. So we said this is a feeder panel. We've locked out and tagged out the upstream breaker. We need to verify that this panel is safe to go inside of and maybe replace some breakers or whatever. So we do a shock risk assessment, the first thing. The next thing we're going to do is an arc flash risk assessment. That information, once again, is on the label. And it's going to give me the incident energy at a given working distance. So let's say that my, most typically working distance on a panel board like this is going to be 18 inches. So our engineers do a calculation and they say that 18 inches away from that arc flash, I would be hit with so many calories per square centimeter, whatever it is, 2 calories, 2.4, 1.7, 4.8, whatever it is. Okay. I need to make sure that my skin is protected so that I don't get any burn injuries. So I must select some PPE that's going to equal or at least equal, if not exceed, that calorie rating then, right? So that's what I'm going to do in order to minimize my hazard, as well as select other PPE that I need to feel safe from the arc flash hazard inside of that panel then. So the first thing I have to do then is I have to do this risk assessment. There's an excellent example in the back of NFPA 70E in an informative annex that has a matrix in order to help you determine the risk assessments for shock and arc flash protection then. So whether you develop your own or use what's in 70E, make sure that you have a written, documented risk assessment for each and every step that you do on this electrical job then. The next thing that you're going to have to do practically is, so you do your risk assessment, it's documented. You look at your risk assessment, you go, oh, well, this is the PPE I need. I need this level of rubber gloves. Maybe I need a face shield, okay, with a balaclava and so on and so forth. You determine all of that from your risk assessment. You have to select the appropriate PPE and you have to inspect it and make sure that it's safe to use. Okay. When it comes to the ARC rating on your clothing, you will not only want to inspect your clothing to make sure that it is no physical damage to it and so forth, and it's not grease or oil on it and anything like that, but for sure you want to inspect the label. And the thing that I'm looking for in the label, one of two things. I'm either looking for an ATPV value or an EBT value. This one says ATPV, 10.6 calories per square centimeter. That means that this is designed to protect me up to a 10.6 calorie arc then. Important information. So make sure that you properly select your PPE, okay? The same is true in my gloves. Make sure that your gloves are voltage rated for whatever the particular equipment is that you're going in to work on then. So we select our PPE. The next thing that we're going to do is we're going to make sure that our equipment is suitable for normal operation. So before we ever pull this cover off, NFPA 70E gives you 6 items to look at to make sure that this equipment is safe to operate the breakers on the outside or pull the cover off and go in and verify an electrically safe work condition. So what are those things we're looking at before we ever pull the cover off? Well, first thing, we want to make sure it's properly installed, it's been properly maintained, that it meets all its requirements for whatever its use is for the manufacturer's instructions and UL and so forth. We want to make sure that all the covers are in place, that all the bolts would be in place before we'd operate anything on this equipment. And we'd make sure that there's no signs of impending failure. If we meet all of those requirements, then we're safe to pull that cover off if we follow where the appropriate PPE and follow all the safe work practices in. Then if the equipment looks good and we're ready to work, we want to set up our boundaries and go to work. So we set up barricades is what we do. So we look on our arc flash label once again, and we see what is the greater distance, either the limited approach boundary, which is based on shock protection, or the arc flash boundary, which is based on burn protection. Well, I don't want anybody else to get burned around here, and I don't want anybody else to get shocked. So I'm going to set up a physical barricade, red tape, gates, the expanding gates, whatever it is I use. And I'm going to set it at either the limited approach boundary or the arc flash boundary, whichever one is greater. That way, nobody gets injured anywhere around me. Now I'm ready to go inside of that barricade and boundary with all of my appropriate PPE, following all of my company's safe work practices and procedures, and go to work on this equipment and verify an electrically safe work condition. NFPA Article 120 gives you 8 steps in order to verify an electrically safe work condition. Once again, big topic. You want to go through all of that in another training session. In fact, you're required to do that. Your lockout tagout program is required to be audited annually then. And one of the most important parts of the lockout tagout program is the live dead live test. So if we've de-energized the upstream breaker and we want to verify that these 2 terminals bringing the power into our equipment are in fact de-energized, the first thing we're going to do is, of course, we're going to inspect our meter, make sure the meter and the test leads themselves are safe to use. And then we want to use a 3-step method. We want to first make sure our meter works properly by checking it on a known voltage. Then we want to go in and verify from phase to phase across those incoming terminals where the power comes in. And then we want to check from each phase to ground and make sure that we have 0 volts on our meter. Then we want to make sure our meter still works properly. So it's a 3-point method. We first make sure our meter works properly on voltage. Then we check from phase to phase and phase to ground on our equipment. And then we go back and make sure that the meter still works properly on voltage. Now I could use a receptacle in order to check to make sure that my meter works properly. One of the most common things that we have now, we see a lot of out in the field, is various types of proving units. So I can take and put my proving unit very close to the equipment that I'm working on, is an advantage. And then I can come in and I push those little two buttons in and my meter would read 240 volts, let me know that it works on voltage. Then I come over here and I check once again from phase to phase and phase to ground, make sure that I get 0 voltage, and then come back and make sure that my meter still works properly. 3-point method, or live dead live test, we often call it. Once I create the electrically safe work condition and I've verified that this equipment is safe to work on, and I did in fact lock out and tag out the correct breaker upstream, I can now go ahead and take off all of my PPE, except what's required for my normal PPE in my company to wear, and I can go to work on this piece of equipment then. So anyway, those 5 steps: perform your risk assessment, shock and arc flash risk assessment, then document it. Number 2, select your PPE based on the results of your shock and arc flash risk assessment. Number 3, before you touch anything, verify the equipment is safe to operate. 6 steps required there in NFPA 70E. Set up your barricades. Know where your boundaries are. Look on your labels at either the arc flash or the limited approach boundary, whichever is greater is where you want to set up your physical barricade then. And then finally, you're ready to go to work. Go in, establish your electrical safe work condition, follow all the steps in Article 120 for creating an electrically safe work condition, and most importantly, do that live dead live test we just demonstrated then. So that's it for today. That's everything we've got. Looks like we're about out of time. Go back, review your NFPA 70E as you need to. Make sure you still get your qualified worker training. You get your refresher training every 3 years. This course, or excuse me, this Tech Talk does not substitute for a course on electrical safety. This does not meet your 3-year refresher requirement training. And so make sure that you go back, you get whatever training you need. You should be audited in the field annually to make sure that your procedures are working and you're able to physically comply with those procedures and you understand them. And your electrical safety program must be audited every 3 years. If you don't have your labels on your equipment, until you get them on there, make sure you use your PPE category method in Article 130. So that's it for today. It looks like we're out of time, as I said. And so we thank EC&M Magazine at ecmweb.com. It is in the portfolio of the Endeavor Business Publications. And so we'll be back with you on the next Tech Talk, which is going to be on boxes. Boxes, oh yeah, things you'll find in the National Electrical Code as well. Maybe some things about boxes and enclosures that we see that are not in the National Electrical Code, then we'll have some fun with that. Okay? So until next time, work safe, or nothing else matters out there. I'm Randy Barnett, and thank you for viewing this EC&M Tech Talk.